told you.
See if I can sneak off his view. Can Chris keep up with me? All right, here we go. So breaking a little bit of the norm here. It is a Friday night. We are doing guild night. Changing it up a little bit. We've got a special guest came in for you guys. Flew all the way in from North Carolina to do this workshop tonight. So I will be brief. We will get to the hands-on portion and have fun. Guild news. Next week, if you have not built CTF challenges before and you would like to, that's the week to show up. John's going to do a quick little how-to. Here's how you do it. Here's how we set stuff up. They'll probably run you through how to set up an instance of CTFD and some other fun stuff. And then we'll get to building challenges and trying to get stuff squared away and solidified for B-Sides Tampa. Again, if you are participating and you have not, if you would like some coin for making a challenge, we are offering bounties for challenges for B-Sides Tampa. We would like to see the guild participate as much as possible. So feel free to help out and make a little bit of money when you do it. We're also looking for volunteers, and I've talked to a lot of you already for the day of, to hang out in the room. We've got our own space at B-Sides Tampa. They messed up and gave us dedicated space. So there's that. If you would like to help, feel free. We're always looking for volunteers to help with that. The week after is lightning talks. If you have never done a talk before down here, if you are very bad at public speaking and you do not like standing in front of people, that is the night to get some practice. It's short form talks, 15, 20 minutes, a half hour maybe if you decide to run really long. But the choice is you, what you talk about. You can give a talk on basket weaving. You could talk about how you brew mead or you just built a house out of logs and sticks. Whatever you want to talk about. It can be super technical with demonstrations. It could just be you running your mouth with no slides for 15 minutes. Does not matter. 2 weeks from now, that night is for you guys, all right? Come out, get some practice, and have fun with it. After that, that will round us out to the 30th. The 30th is going to be a fun one. This one is going to be a closed session, so if you are not a member of the 30th, you cannot be here. For those of you that are members, on the 30th, leave your phone in the car. Or if you bring it in, we're going to have a box for you to put it in. This is a no stream, no video, no phones, none of that. Don't bring your computers in. You won't need it. It's going to be a good talk. It's a very sensitive topic, very sensitive nature, but it's going to be real-life cyber clue. It's a whodunit mystery that our speaker is going to walk us through. And this is something she experienced in real life, so it's going to be good. A lot of defer happening in her life, trying to figure out where she actually was, proven innocence, like full-on mystery. So it'll be really cool. That's on the 30th. From there, that takes us to B-Sides Tampa, April 1st, April Fool's Day. Show up, come support a good cause. There's a lot of good speakers, a lot of really good keynotes. And I think we've got, what, 4 or 5, maybe more speakers that are all Temple members already. So if anything else, just come support your brethren and brethren. I think that is news, right? Yeah, I did just make a word up on the spot there. Anything else? Did I miss anything? My normal cohort of rabble-rousers aren't here to tell me yes or no. Okay then. Well, that is all I've got. Let's introduce the speaker. So Bob, I'm in here. I've known him for a few years now. We work together at Hack the Box, making content on Hack the Box Academy. He is working in the collegiate system. I'll let him talk a little bit more about himself, though, and what he's doing there. He flew down here to do this workshop for us this weekend. So take advantage of it. Get the most out of it, what you can. The man is brilliant. I value him as a person, as a peer, and as someone I've worked with for a while now. I can't think of anyone better. So with that, we'll go to the intro and give you to Bob.
Awesome. Hello. How is everybody doing this evening? Doing good? I'm Bob Tyson, and thank you. I appreciate that. Cool. I'm Bob Tyson, and I am fed up with the way the education system is. I'm just saying it like it is. I came from a situation like you all did. A small setting, community college environment. I know it's not a college, but it is a community, and you all learn and look out for each other. And I started my career at the community college level. I was doing car washing at the time. I didn't think I could learn. I didn't think I had the ability to break into a field as logical and as intellectual as IT and cybersecurity. And I met a community. And when I come in here and I look at all y'all interacting with each other, it brings encouragement to me because I believe the educational system is failing people. So if you've gone through a college, you kind of have probably felt this a bit, where maybe they're not trying to reach you, maybe they're not really trying to teach you, they're just trying to maybe take your money. I'm not saying it's all colleges, but it's a lot of them. So when I go out to any community or do any speaking engagements like this, I want to spread awareness of the fact that you deserve a high quality education no matter where you go, especially at the college level, and that you have a voice. So I just want to ensure you know that. Now, that's not the only reason I'm here. Anywhere I go, I'm trying to champion and evangelize about education right now. So a little bit about my journey and where I came from. Again, I started at the community college level, and I didn't know what I wanted to do, right? I didn't know if I wanted to be in business administration, and that was my first major, or what. I just kept going through my studies, and I came across an introduction to computers class. And for some reason, that class, the topics resonated with me. And for the first time, this is over 10 years ago, by the way, for the first time in my life, I had felt a sense of purpose and a sense of interest in learning. And you all are here, so you already know you have an interest in learning. That passion and that interest, you need to follow that. Whatever topic you have an interest in, you've got to follow that with all you've got, because it's going to take you into another stratosphere in terms of your career, who you meet, and the impact that you have on the world. So this catapulted me into a career in IT. The first job I ever had was working for a small tractor sales company, and they fixed tractors, and I was basically the lone IT ranger. Have any of y'all in here been a lone IT ranger before for a company where it's like, it's you. When something goes wrong with the printer, it's you. If it's a security issue, it's you. Ransomware, you, everything. So I trial by fire went through that. I got a job working for an MSP in Statesville, North Carolina called Integrity Computers, which really accelerated me some more. That was a small community. About 8 of us supported over 200 companies. I had no idea 8 people could do so much. So as you look at the people around you in here, and as we do these things, and as you go to different workshops and get-togethers that the temple does, don't take that for granted. You may be able to form companies out of this kind of focus group. So I'm just saying, look at what you've got in front of you and the people around you. After that, I stayed in contact with my mentor, who was like the best teacher I ever had in IT. He helped me learn networking. He helped me learn just about everything I know now. He laid my foundation. And I stayed in contact with him, and he had really implanted in me a passion for education. And as I started to see the way that the educational environments are, particularly in the way they're teaching IT, I felt that the sense of purpose and what I believe to be God calling me to be an educator. So ever since then, I got bit by that educator bug, and I've been trying to teach as much as I can. I created a YouTube channel during the pandemic. A company called Hack the Box discovered that YouTube channel, and I got a job with Hack the Box. I worked at Hack the Box with Trey for about a year working on the Academy platform. We did a lot. We did a lot of innovative things that are now being discovered by the industry within the ethical hacking and penetration testing space. But I felt a pull that I had left behind unfinished work in the college environment. So that's where I am now. I teach currently at a community college in North Carolina called Caldwell Community College. And my main purpose, I believe, in life is to change the educational system. So I hope that when I talk about some of this stuff, I hope some of you all would join that mission because there's quite a need for it. Now, I didn't come here to do all that. I did come here to talk about computer networking because I believe that in cybersecurity and IT, computer networking is often missed. People want to jump to the hacking. They want to jump to the blue teaming, that they're missing the IT foundations and fundamentals. So today I've got some lessons for y'all. I've got some challenges on hands-on equipment, and we're gonna get it rolling. So let's start the actual talk. That's just my intro. So this is one net to rule them all. The reason I wanted to call it this was because although technology changes all the time and we hear it's always evolving, the ball of technology keeps on rolling, right? Networking really hasn't changed that much over the years. The core foundations of networking, if you can get those, you can build quite a great career. It's going to translate to so many different disciplines within IT and cybersecurity. And I do put those together because I think every IT professional should also be a cybersecurity professional. So let's start off talking about the one network to rule them all. That is the internet. What is the internet? And feel free to shout at me. You know, what is it? Porn. Someone said porn.
Internet-connected devices.
Internet connected devices. Right?
Would you say it's a bunch of interconnected things?
A bunch of interconnected things, yeah.
A network of networks.
The one network to rule them all, right? Are we connected to the internet right now? Probably. You know, I can't remember the last time I was not connected to the internet. My phone, wherever I go, unless I've got Wi-Fi or cellular turned off, I'm connected to the internet. So the internet, and we'll learn more about it, and you'll actually do a lab that represents in a small scale model the entirety of the internet. You'll see some switches and routers over there on that table that you'll actually be interacting with later. How do we use it? And I promise we'll get hands-on. I just like to look at it from a big picture first. How do we use the internet? And there's so many different things that have been revolutionized by the internet. Anybody have any thoughts that, like, just as they think about the internet, that just sticks out to you? I didn't hear that. What was that? Minecraft. I mean, Minecraft is quite amazing. Isn't it like the best-selling video game of all time? It's still popular. People still play online, play together, build together. Video games, right? I'm a gamer. How many of y'all are gamers and online? Put it in the chat if you're a gamer. Yeah, gaming, multiplayer gaming's wild. Cloud gaming, has anybody seen that yet? That's wild to me. Just crazy. I'm dorking out over it. Right? I mean, someone said learning. Learning, I believe the internet has democratized information. It was once the case that you absolutely did have to go to a learning institution to further your understanding of things. Or you had to go to the library's still great, don't get me wrong, but you had to go to the library, get the book, study, find it. The internet has allowed any of us here to learn just about anything we want if we have the intentionality to go find it, right? Search engines, of course, have made it possible to really quickly find information. You know, how about creativity? What we're doing right now, we consider a creative endeavor, right? Where we're talking to, I don't know how many people are online in the chat right now, but potentially we could have thousands, maybe 10,000, maybe millions eventually over the next 10 years see this talk because of the internet. You know, when I first started doing YouTube videos, they were getting 1, 2, 3 views. And then they started getting more. Now, I'm not huge on there, but I have like 1,400 people subscribed, which is not a lot. But you have some of the videos you see get 20,000, and you go into the demographics, and you see Nigeria, India, the United States. And to me, As an educator, if any of you are interested in education, you actually don't have to go and get your master's and PhD to start teaching. You just need a camera, a mic, and a computer and start making videos and teach people. You know, you see these people like Network Chuck out here and these David Bombal and these big YouTubers reaching global audiences, building businesses off of these creative endeavors. Musicians. How has the internet really empowered musicians? Or it took away some things from them as well. It's hard to make money as a musician nowadays, but it's easier than ever to publish art, right? You know, Chris, you're making art all the time and you can put it out there, you know? So art has been revolutionized. So if you're like, I want to be a musician, you don't have to wait for somebody to tell you you're a musician. If you feel it on your heart, you got to make a song and put it out there. That's, I mean, you have to really put yourself out there, and it takes some nerves of steel to really see what people really think about your work. But it's interesting creativity-wise. We already talked about education. What's your favorite way to learn when you use the internet? Do you like videos? Do you like live stream? Do you like just reading? Some people are like, I don't like videos. I like to read.
Whatever gives me the answer the fastest.
Right? Whatever gets you the answer the fastest. Right? CTFs.
Chapter to referential materials I can go back to later.
Yeah.
I got it.
The referencing. Have you all seen the chat GPTs and all this AI stuff coming out, the generative AI? That's going to do some interesting things for learning. My personal favorite thing about learning online is these CTF platforms. You know, your Hack the Boxes, your Try Hack Me's, all those. Because you're basically remoting into a hypervisor that's got VMs, and you can learn on demand. And it's amazing to me. You have to try some of these sites out because you can learn, you can go from zero to job on some of these sites. In addition to being part of communities like this, which I know they're probably going to build some, there's a potential cluster of hypervisors back there in the works that could potentially help you all as well. What else? How about work? Work has been revolutionized by the internet as well. We can remotely work. You know, you could, if you have a job that allows you to remote work from anywhere, you could literally go on vacation and work. You could do a lot. Discord is my favorite chat app. I use it more than iMessage or any of these text platforms. And you know, social media. How do y'all feel about social media? Is it good, bad?
Cancer.
Yeah, someone said cancer.
It's like everything else, it just makes people more what they are. Smart people get smarter, dumb people get dumber. But
Yeah.
it's interesting though, you get people that uproot their entire lives because they happen to meet the right people, they move to a new place, they make a bunch of money, do a bunch of cool things, so.
Yeah.
Nuclear arms are less destructive than social media.
It can be a very toxic place, but I agree with you. It amplifies what's already in you. So if you're hateful deep down, I've seen some hateful people get out there and just say it. Keyboard warriors, right? Twitter fingers turn on. And it's like, come on now. But then there's other things, like I told you my story, how I got a job just by posting videos on YouTube. Someone dropped a comment in, hey, we need to talk. I think we should work together. I followed that. I thought it was a social engineering attempt, but I just was like, all right, let's try it. And it sure enough led to a job, a really good one of the best I had ever had in my life. So I'm not saying social media is always going to lead to those outcomes, but it can be a good thing. Unless, of course, it's TikTok. No, I'm kidding. All right, so let's get more specific into how networks work. So the internet is the network that connects all networks. If you think about what are your major interstates, the way I personify it is I look at it like your neighborhood is a local area network. All the interstates that connect the cities, that's like the internet, right? The internet is a physical thing. It's also a logical thing. What components make up the internet? When you hear the internet, what immediately pops in your head in terms of devices? Switches, routers, cables,
Byproduct of the telephone era?
pots, plain.
No, a byproduct
Oh.
of the telephone era.
Oh, that is.
Networking came from telecommunications.
Yep,
Most people don't know that.
absolutely. It was an evolution of telecommunications. Thanks for mentioning that. So it's cables, wireless signals, fiber optics. What's fiber optic?
Light,
Light passing through what?
glass.
Glass. That sounds sci-fi. When we really think about how some of this stuff works, I'm pretty sure whoever made it was consulting with the aliens. You know, like I really, you know, I'm not serious, but sometimes I really do think, how did we think of this in the first place? You know, I understand how it works now, but I wasn't the one that invented it. That's crazy to think about. I think about it like the highway system. I do when I visualize it in my mind. So what does it look like though? This is the typical topology for a home network, right? Is when you go home, your apartment or your house, you walk into a wireless network, right? Typically, your device connects to the network, and where does it go after that? Where does the connection go? So if I'm at home and I sit down on the couch, I start scrolling through YouTube Shorts, and where does my information go?
Your ISP.
It goes to the ISP, but it goes from my phone, or the request goes from my phone to the wireless router. Then where? How does it get to the ISP?
Towers.
Well, if I'm on cellular, you're right. That's another way to connect to the internet is through cell networks. But what about if I connect to my wireless router at home? Where's that going?
Upstream gateway.
Right, it's like hitting the router, it's going to a coaxial cable, or if you have fiber at your house, it's going underground to a junction box. Y'all ever seen these out in the streets or on the side of a building? That's part of the internet. It's connecting to your ISP. You know, someone can get drunk in the car and crash into one of these, and the internet connection goes down for an entire region. That has happened more than once. Does this make sense? Y'all get this, right? I think most of y'all probably get this. I'm just laying the framework. What are these? What are those? So this is an Ethernet cable, right? We got some over here. Let me grab one. What's in this thing? And all this is going to matter when you start to do the lab later. What's in this thing? Twisted pairs of what?
Metallic objects shielded in rubber.
Right? Okay, but then why? How does this, you're telling me this right here can pass information through it. Like I can send a message through this to you, you're lying.
Yes,
You online, you're lying.
or wire.
Electricity, right? And what's electrical pulses are going through this in a stream of ones and zeros, right? Binary, and somehow it gets to the computer and it's something that's readable. It's wild to me. What is that thing in the bottom left?
What is that, 5G tower?
Right? That's wireless, right?
Sourcing a lot of 2020 conspiracy.
Right? These cell towers are interesting to me too. It's a wireless extension of the internet, right? So when you walk through a building, wireless access points extend the local area network. Cell towers extend the wide area network of the internet, right? What are ISPs? The gatekeepers for the internet, right? We do pay for access to the internet, right? But it's through the ISPs. They deserve to make money because they're maintaining all that infrastructure. Cool? Satellite's another way, right? Have y'all seen Starlink? Anybody played with Starlink? I've yet to play with it yet, but I really want to. Is it as cool as they say? It is. I saw a video, a guy was like setting it up. It was calibrating with the constellation of satellites. Is it pretty reliable? I don't know.
That's been for me. Once you got a clear view of the sky, it works in the middle of the jungle.
That is awesome. I got to try it.
Hey, Bob, hold up real quick.
Yeah.
Who drives a white Ford and Spark right here in the front?
A white what?
Ford. White Ford. Anybody?
Why?
This is getting towed away. I would say you pay for it, you might want to.
Is my black truck still out there?
Yeah, I'm parked right there too. Evidently, our parking lot is no longer ours after 5 on the Yeah.
I put it out
So
on this.
we might want to take a short intermission so
Okay.
you can pay for parking.
Hey, we're going to take a short intermission so people's cars do not get towed.
That's the quickest way to clear a room.
We're back on camera, at least. Just word otherwise.
Okay.
Sorry about that, everybody at home. Some people were getting towed, so we had to do a mass exodus over to the old Undercroft building to find refuge for our cars.
I'm just having my partner get towed as well. I got to do one ticket. Did you really? Yeah. Did you pay your parking? No.
Wait, did you? Wait, your car got moved?
No, you got a ticket.
Wait, tonight?
I got a $50 ticket, yeah.
Tonight?
Yeah.
Where do you park at?
I'm straight up the
Where's
door.
everybody else?
If you're in the lot, you're screwed.
I parked in the paid one next door.
Unless you back.
But did you move over there?
Yeah, I moved.
Oh, and you got the code?
Yes.
Okay.
Oh, no.
So just park over there from now on.
I appreciate it.
Yeah.
But I don't even see like you enforce paid parking. If you even have to pay.
Yeah, my company. For that. Yeah, so I told my heavy center, but this company, I got a job with them. So.
Oh, so if you haven't done anything, then I wouldn't do it.
Yeah.
Well, I just got these tickets too.
Same place, yeah. Okay, Bob, you want to go ahead and
Yeah.
get back into it?
Yeah, we can keep going.
Okay, go for it.
I was fighting.
All right, we're back from intermission. Hopefully for those of you that had an unfortunate situation with the parking, this will be worth it. So let's keep going. So I was just talking about the media that make up the internet and networks, Ethernet cables, which have copper wires inside of them, right, that are conductors of electricity, cell towers and cellular technologies, part of the wireless spectrum, right, fiber and satellite. One thing about wireless, there's another magic sci-fi technology, right? I mean, we're talking about information packets traveling through air in the electromagnetic spectrum from one point to the other. That is also sci-fi. That is also alien technology, in my opinion. I don't know how it started, right? I mean, Tesla, right? Some people say it was Nikola Tesla that really started the whole wireless potential with the technology there, right? So look into radio technology, radio frequency, and then look at Tesla. I'm not saying he was the main one, but he's attributed a lot of the times of being the pioneer. So we mentioned these devices earlier, right? Switches, routers. What is the difference between a switch and a router?
A router will only stay still at whatever the domination of pass or throughput it has. It will say if it's 100 or 10 bit, it'll only do 10 bit. It also won't exchange the ports. Where a switch, you can exchange ports and float ports, and it'll give all the ports at the same speed at the same time. Where a router will, if you got a 100 meg or 10 meg, 10 meg router, it'll only do 10 megs at max, where a switch will do from 10 to 1,000, whatever the switch number is.
How about in terms of how switches and routers make decisions? What's the main difference between a switch, and I guess I'll use the OSI model terminology, layer 2 switch and a layer 3 router? Someone in the
So while a router will maintain a table of like external network addresses, so that you can go from the inside network to whatever other networks it's connected to, whether that be the internet or another network within your infrastructure.
right? So the way I look at the core difference between a switch and a router, a switch makes forwarding decisions primarily based on MAC address, right? So the layer 2 PDU is a frame. So when data gets packaged, are y'all familiar with the OSI model? If you're not, it's a reference model that explains the process of encapsulation and decapsulation of data as it goes over a network and is received by a computer. And the main difference when you look at the OSI model between layer 2, which is predominantly what switches are considered to be, and layer 3 is a layer 2 switch forwards traffic based on MAC address. Layer 3 is based on IP address, which when you hear a layer 3 address, that's an IP address. Also, they talk about in the OSI model, a layer 3 PDU is a packet, where a layer 2 PDU is a frame. That's like certification knowledge. It can help you, if you pop up in Wireshark and look at it, but when you're making that differentiation between PDUs, that's typically certification knowledge in my experience. But it does matter. If any of you are going for a certification, whether it's, I don't know, Net Plus, CCNA, even a lot of Security Plus, a lot of those are network heavy. I'm not a huge fan of the CEH, I will say. I took it. It was network heavy. It wasn't a lot of hacking tactics. It was a lot of networking. So my CCNA helped me with that one. And then ethical hacking in general. So if you're trying to get into pen testing, networking will really help you. If you're doing network-based penetration testing against services on a network, Active Directory, all of that, networking is going to help. Now, web application pen testing, you may be able to get by without knowing as much networking, but if you're looking at going on engagements and hitting an entire network, you should know networking pretty well. If you don't, then hopefully this lab and this will help today. Protocols are important. What is a protocol? On a network, it governs communications, right? So if we were to open Wireshark, anybody got Wireshark on their computer now? You would see a bunch of different protocols, right? That's what that's what Wireshark is a protocol analyzer. You can see everything leaving your computer, coming in. So there's so many different protocols. Let me go back. I'm not going to talk about all of them today. There's lots of them. But here are some of the main ones, right? TCP/IP, UDP. We talk about IP version 4 and IP version 6. And let me ask you this. Are we completely away from IPv4?
No.
Why not? It's so old. IPv6 is brand new. I thought we were in technology and we're the latest and greatest with everything. Why did we stay with IPv4? Why is it still so ubiquitous? Anybody know? I blame NAT too. I think NAT made us lazy because, hey, address exhaustion doesn't matter on the LAN when you have NAT in place. Somebody fight me online if you really think that that is not the case. What types of companies benefited and moved to IPv6? Or which type of companies would you say and organizations benefit most from trying to get on IPv6? Because it does have benefits. Hosting providers. I would say a lot of web companies, like companies that their business relies on the web. Your social media companies. When you look at the Internet Society has some statistics on this. If you Google ISOC or ISOC, IPv6 statistics, you'll see a lot of it is internet service providers and cellular providers that move to IPv6. It's very likely if you connect to the cell network and you look at the settings on your phone, you probably have an IPv6 address assigned, global unicast. A lot of computers have an IPv6 and an IPv4 address, dual stack. We may get to IPv6 today, but I still teach IPv4 mainly because it is still the dominant internet protocol in the enterprise LAN. In my experience, the LANs I come across, I see IPv4. When I do IP config in Windows or ifconfig or IP space add, I'm seeing IPv4. Cool. We're going to talk about some routing protocols as well, but I'm not going to talk about that till we get hands-on. All right, how many of y'all feel comfortable with the application of IP addresses? Do you know where to put an IP address? Do you know about these here, the different classes? You feel pretty good about that? I will say, and for most, this is going to be really beneficial to know. So like if you have to take a picture of that, screenshot it, you know there's different classes of IP addresses and there's different classes of subnet masks. These subnet masks are not shown on this slide. Do we have to use a Class A subnet mask with a Class A IP address scheme? So is it like mandated? It has to be, if I use a Class A IP scheme that starts with 10, do I have to use a Class A subnet mask, which is like 255.0.0.0? No, it's classless, right? We're keeping it classless, which means you can use a different class of subnet mask. Do you all get why you would use a different subnet mask with a certain IP address scheme? I'll cover that.
It opens up the ability for multiple subnets?
Yeah, I mean, what does the subnet mask do? And this is where we're going to start getting into the lab. But yeah, a subnet mask will technically, and you can write this down, type it out, whatever, remember it. A subnet mask, if an IP address is like a phone number, the subnet mask is like an area code. The subnet mask defines what portion of an IP address is in the network or has network bits, and which portion of the IP address has host bits, which are zeros. Host bits are zeros, network bits are ones. Does that make sense? So when we look at an IPv4 address, it's in dotted decimal format. The network bits are ones, the host portion is zeros, and there's an IP address and a subnet. Every IPv4 address is 32 bits total, right? So it doesn't mean all 32 bits are ones or all 32 bits are zeros. You just know a combination of ones and zeros is limited to a maximum of 32 bits, right? And then there's 4 octets, which means it's 8 bits per octet. So anytime you see a number in between each period, that's an octet. Does that make sense? Cool, cool. How do you go from decimal to binary and binary to decimal? Have y'all ever done this? So this is something we may not harp on too much today, but it's an important concept for a lot of cert exams. And if you work at an ISP where you have to calculate subnets and host requirements, you should be using subnetting. You should be knowing what subnetting does. In a nutshell, and I would say if you're starting your studying of networking and subnetting, memorize this right here. You could take a picture of it, you could watch the video again, screenshot it, memorize this. In short, it uses the base 2 numbering system. So when you think about an octet, for example, if I was looking at this octet of all 255s, I would know that there has to be how many bits per octet? What did I say in the last? 8, right? So how many ones are in this octet?
8.
How did you know that?
Because it starts at 0.
Right? And because when you add up 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you're going to get 255. So it's this is really hard to do until you've, in my opinion, memorized this. And yes, you can use subnet calculators, and they do work. But when you're on a cert exam, I will say a lot of them require you to do this. Like there may be several questions on there that give you a different subnet mask and say, given this IP address, what's the network address? And you have to know how to do the decimal to binary conversion. But I'm just showing this slide to say, memorize this, that each binary digit has a decimal representation. And when you think about it from the left to the right, in an octet, it's always going to go 128, 64, 32, 16, 8, 4, 2, 1. So I'm not going to bore you with subnetting in today because it can get boring. So we're going to get right into doing some of this hands-on stuff. So let's get hands-on. How many of you have heard of Packet Tracer? I'm going to do some demoing in Packet Tracer, but what I want y'all to do, if you have your laptop, if you don't have a laptop, partner up with somebody with a laptop and connect to one of the switches. So How do you do that? Have you ever connected to a switch before? I think there's a few in here that have. If you want to, come on over here. We have 8 switches right here. If we need more, we've got more too. On the back of a switch, it's usually on the front of a Cisco router, there's what's called a console connection. You'll need a console cable, which looks like this, and it has an adapter with it. If you don't have the port on your laptop is probably not, there's probably no console port on your laptop because it's an older type of connection, but there are what's called USB to console or USB to serial adapters that will allow this to work. There's also USB to USB console cables too. That's if your switch or router has a USB console port. So you're going to take this, connect it to your laptop with an adapter like this here, and then you're going to make sure that the switch is on. How do you know if it's on? I'm not trying to insult anybody's intelligence. Lights are blinking, right? And you can hear fans. What are these on the front? What do they call these? Yeah, RJ45 ports or switch ports. I'm always careful about the language, switch ports, because there's also logical ports, right? Like if you're doing ethical hacking and you use Nmap or some other enumeration tool and you target an IP, what does Nmap return to you? Ports, right? So but these aren't the same types of ports, right? These are switch ports. So we'll talk about what ports do as well. So go ahead and connect to that. What does this do for me? What can this do that this can't? So if I'm showing this switch, what's the difference between this switch and this one? Someone said managed and unmanaged. Those terms, where do they come from? Some people say this is a dumb switch. I'm like, hey, that's insulting. But this has some intelligence to it, right? But I can't do any configuration of it. Like I can't connect in console in or SSH into this or ping this or do anything other than it just plug it in and it works. The reason I say it has intelligence to it is because there is firmware on it that is doing what a switch does, for lack of a better term. Do you remember what I said earlier about switches? How do switches make decisions again? Primarily based on MAC address, right? So what does this do when I connect to it? When I connect a PC directly to a switch via Ethernet, what is this doing as soon as I connect to it? Same with that switch. It's learning what? Switches learn MAC addresses. It's learning the MAC address of the NIC on my computer. Why is it doing that? Does anybody know why do switches learn MAC addresses? Because they just like to learn. They're just like, hey, I like learning. Oh, somebody was saying something. I'm sorry. They're trying to build one-to-one connections. Thankfully, I've rarely come across an actual hub in my life. But switches are different from hubs in that a switch tries to build a one-to-one connection by using MAC addresses. Unicast communications, right? So one-to-one instead of broadcast everything. That's what a hub does. If you ever come across a hub and you're helping a business out, you're going to be a hero because a hub broadcasts everything that it connects to. These learn. So it's not completely dumb, but you can't manage it. Meaning I can't put an IP address on this and connect to it over the network. I can't monitor it really. Now Netgear makes managed switches. They do, but this is not one of them. Does that make sense? Cool. What else? Oh, here's another thing. I can't create VLANs on this. Anybody know what a VLAN is? We'll create one today. VLANs are perhaps one of the most important things to learn in networking. So, cool. Has everybody got a connection with a switch? At least over here.
If we need more cables or anything, let us know.
We might need some more.
There should be a couple couple more console cables, and I don't know if I'll reach across the.
So I'm going to do all this in Packet Tracer so people online as well can
I have
see.
USB-C console cables, so you don't have to waste USB on somebody who doesn't have it.
Well, I'll use it.
So somebody that might not have it, might be that one right there.
You need USB yeah, this one's C.
Yeah. That way somebody can use a USB there.
Here's another one for A. I have an A here. Doesn't need to slide over here. I'll put another table over to use this table for your laptop. Put that in, yeah. You need to make more space.
Don't worry about
Cool. So as you're connecting, I'll keep talking about what's going on. Why would I ever do this over just connecting to something over IP address? Because ideally you want to set these up so you can connect to them over an IP address or over SSH using the IP address. When would I use something like this? And people online, you could say it too. I would use it for initial configuration. So if I just bought a brand new one, it doesn't have any configurations on it, that's when I would do it.
I don't have my laptop.
Also, if I'm in the telecommunications closet where that switch or router is, I would do that as well. Most of the time, it's when you're doing the initial configuration that you're going to use a console connection. Otherwise, you're going to want to give it an IP address so you can connect to it over SSH, remote access. The official term for this is considered out-of-band management, which is short for out of bandwidth, which basically means you're not using IP to connect to it. You're just using console. Cool? Is there anybody having issues connecting to their switch? When you connect these adapters, keep in mind what has to happen. This is an operating system thing. When I plug this adapter into my PC, whether I'm in Linux or Windows, what should happen, what needs to happen when you connect a USB device to a machine? The operating system should load a driver, right? If it does not recognize this, you probably have to get the driver. But if it does, good. Awesome. In Windows, where do I go to check to see if I'm missing a driver?
Device manager.
Device manager, right? Exactly. That's where I go. So I plug in, I'll open up device manager, I'll hit enter, and I'll look for anything that has like a yellow triangle next to it. If I see something that has a yellow triangle next to it, I'm missing a driver. If there's nothing and you've plugged your adapter in, you've got your console connection as well, expand ports. See where it says ports, COM, and LPT? Expand that. You see this, it should say the name of the adapter, and then in parentheses, you'll see COM, some type of COM port. Mine says COM3, yours might say something different. Do y'all see this?
Yes.
On your side as well?
Yes.
Cool. Now, what do I use to actually connect to the switch interface? And we're going to do command line interface. We're not going to be GUI babies today. Putty. Or what's the generic term for a tool like Putty? What do they call it? A terminal emulator. What is a terminal? Have anybody ever played Fallout? The Fallout series of games?
Yeah.
I love Fallout. You know the terminals in that game? You like connect to this old, what is it, like a CRT monitor that's buzzing, right? The Pip-Boy, right? It's like buzzing at you, and you're connecting to a mainframe, right? The terminal has no power, right? It's not a desktop computer. It's just used to connect to an interface. So that's what PuTTY is, and TerraTerm and XTerm. There's a bunch of them. You connect to a command line interface of a device that you're wired into. Cool? So in Packet Tracer, that's generic. You go to desktop and terminal. But in real life, you have to get PuTTY or TerraTerm. Okay, so what am I connected to? What do y'all see? I might have to zoom in. For you, what do you see on your prompt in PuTTY? What's it say? Does it say switch greater than sign?
Yes and no.
Yes and no?
Their name.
Say no to that. Oh.
Their name specific temple and an S1.
Right. So some of these might be called switch. Some of them might be called temple. I did name them. But this is a prompt, right? Anybody familiar with a Linux operating system? When you open up terminal, you see a prompt, right? Host name at, username at, host name. Similar with Cisco IOS. I learned Cisco IOS before I learned Linux and Bash and all the different, command language interpreters in Linux. I like Cisco IOS because it makes things quick once you know it. It makes things quick. And it really forces you to pop the hood and see what happens on a network. That's why I still teach it. Not that Cisco's as dominant as they once were. They're still out there in the big companies. But knowing Cisco IOS can help you learn how networks work under the hood. It really can. So what you see is a prompt. You see the host name and then the greater than sign. Does anybody know what that greater than sign is? What does that mean in Cisco? Oh, you're...
Oh, is that enabled, or is it Cisco?
Yeah.
Greater than sign.
The greater than sign is user exec mode.
What mode is that?
It's user exec. So the mode I'm in right now in Cisco IOS is user exec. Very limited. You can't do a whole lot in this mode. So we're going to go to another mode. Follow along with me. Do EN. Yeah. Yeah. Let me zoom in, actually. Is that good?
Better. Mine's better. Thank you.
So EN is short for enable. But you type EN because I'm lazy. And I hit enter, and the prompt changed. What does that mean? The pound sign or the hashtag, whatever you want to call it, I changed to privileged exec mode, which gives me a lot more features. And we're not going to say every single thing you can do in privileged exec, but you can do a whole lot more than in the mode.
What's the general difference between the two?
You can make more device-wide changes in privileged exec mode. Like I can save configurations. I can delete settings. Like I could delete VLANs, the VLAN database. I can't do any of that from user exec. In my career, I've not used user exec much, honestly. It's like a mode that I use to get to privilege exec.
Does the command line have over the GUI?
Speed. Speed and the ability to automate, right? I mean, we could open up, I know this isn't full-blown scripting, but it's a low-level version of it. We could open up Notepad right now, type all the commands out to configure a device, and just run them right from the command line. For me, it's speed of configuration and management.
Hey, Chris.
Surely you can place a password. It shouldn't be that easy to become privileged.
Yes, and I'll show you how to do that. And you're right about that. Same is true for when you connect a console cable. You can set a password on that line to make sure not anyone could just come into your telecommunications closet, plug in, and be in. Although, in any case, when someone has physical access, they can probably do some damage.
Yeah, so for those of you that are familiar with Linux or even using like PowerShell in CLI, the big difference here when you think about user exec mode, it's like being a basic user, or let's say your boss wants to oversee all of your stuff, but you don't want him making changes. You give him user exec rights, and it's basic view permissions, They can't make any system changes that would affect the functionality. Think of privilege exec mode as having root on a Linux box or running terminal, PowerShell, whatever you want as administrator. From privileged exec, you can control anything and everything about that host. Make sense?
Absolutely. That's a good way to look at it. So do you think devices like switches and routers are also targets to hackers? And if you're an ethical hacker or penetration tester, if it's in scope, might you want to target a switch as well? Because those are in scope in a lot of engagements. Not all of them, though, because they could disrupt a lot, right? This is different from hitting one box. This is hitting a machine that's responsible for connecting that whole segment of a network, right? So you could see why some organizations wouldn't want that to be in scope. But a malicious hacker doesn't care. They're like, who cares what's in scope or not? I'm just going after it, right? Cool. So if I didn't know what commands to do next, what do you think I could do to see my options?
Ask it a question.
Right, help, or how about this, question mark, and it shows you all the options. Now, do you need to know every single command that ever existed on a Cisco device? No. The only reason I've memorized commands like this is, one, I've taught it for several years now, and I only memorize things I use regularly. I won't intentionally go in here and try to memorize all these commands. Although if you've got the time and you find that very fun, go for it. But that's not going to be me. I'm not going to be the one that memorizes every command, but I have a lot of them memorized because I've taught CCNA stuff for several years. So we want to go to an even higher level mode. We're going to go to global configuration mode. So type CONF space T. That's short for configure terminal. And press enter. Notice the prompt changed to, in parentheses, config, and then the pound sign. Now we're going to start making changes to the switch. And feel free to make changes to these switches. I'm just going to name this host name. So I'm going to name it temple-bob or temple-sw-01.
Is anybody in here that's trying to follow along having issues?
Password protected.
Yeah. On yours? Yeah, you're going to have to do a lot more.
Try temple 1,
Yeah.
capital T. Because there was one of those I put a password on. That work? Cool. But you notice how that one had one. Because I was setting up SSH on one of these earlier. And you have to put a password on. SSH requires you, and these switches require you to put a password on the privilege exec or the enable command for SSH to actually work. So how do you set a password? Someone asked that earlier because they're security minded. And by the way, security is a mindset. It's not any specific technology. Certain technologies are built with security in mind, but it's my experience that security is a mindset. So do enable secret and then type the password after that. So I did enable space secret space whatever I want the password to be. Right now, just for the sake of today, I'm making it something basic, temple 1, enter. But in real life, should I have done this that way? Like in a real situation?
We've got a question for you here, Bob.
Oh, yeah.
How secure is that password?
It's not very. So, but it is a barrier for an attacker to not just easily get to privilege exec mode. But these passwords, I'll show you this. You don't have to do this command, but I'll just show you this. When you do secret, it's encrypting the password in the running config file. But this level of encryption can actually be cracked. There's online crackers that you can literally copy and paste into, and it'll show that in clear text, which is why it's important that what? Go ahead. I was going to say that you make your passwords more complex, right? Because crackers can take longer on them.
So the type, it says type, I'm assuming 5 means type 5, is that what the top?
Yeah, I think it's, if I'm not mistaken, you might have to Google this, but I think it's an MD5 hash is what Cisco uses.
They have several different variants. So the 5 is specifying Cisco Type 5, which is easily cracked. The other really, really bad one is type 7. If you literally go to packetlife.net, you can input that hash and it's going to give it to you in a refresh.
Yeah.
So
If it's like a shorter password, but if you, though, that's why when you're doing passwords like this on network equipment, make them complex. Like use a password generator. So, cool.
One follow-up question.
Yeah.
Since we're entering the password as a command, logging, are commands logged? Is that something someone can?
You have to turn it on.
Okay.
Yeah. You would have to turn on logging, but it's not by default like logging keystrokes.
So the question there was, is as we put a password
Yeah.
password into the terminal and typing it clear text, is it logged? By default, no. You have to enable logging for it to actually write that history. And when it shows up in the running command, as long as you use secret and you specify a higher level, it'll be hashed. And if someone manages to get a copy of your config, they'll get the hashed version. They won't get clear text.
Yeah. Although every successful configuration I'm doing here does get saved in a text file in a Cisco device called running config. So all of this I'm doing when I did the command show run, I'm doing show running configuration, which is literally a text file in Flash on this device, which has been loaded into memory. And anything I type that worked is going to get stored in here, and that you see enable secret. So later I'll show you how to save your configurations on a Cisco device. But for the most part, just know working configurations get put in a file called running config. Cool? Yeah, no problem. All right, so we set a password. What does that password do? It put a lock essentially on that enable command. So not anyone can do that. Some organizations, I know companies I've helped send talent to, hardware stores, big hardware stores I'll say, that use Cisco, they will actually integrate Cisco devices on their network, because you can imagine thousands of switches and routers for big corporations. It doesn't make sense to manage like passwords on each individual one. They actually build in integration with Active Directory. Do y'all know what Active Directory is? So they might use Radius, or they'll have their own, what's it called, TACAC server, where it's like any authentication that is happening on the switch or router goes to a server that's centralizing authentication. We won't get that far today. We're just worried about individual devices. Cool? All right. Now, what we need to do is I want to show you and talk a little bit about how the switch learns MAC addresses. So each of these switches here has what's called a CAM table, or a content addressable memory, also known as a MAC address table, where it's keeping track of the MAC addresses of devices that are connected to it. Are your switches right now going to have MAC addresses saved, you think?
You've been playing with them.
Right. If I connected to any of the ports, they would. But for the most part, they may not on those, just because I didn't connect Ethernet ports to those. Or Ethernet cables. Some of those have Ethernet cables connected. So what I would ask you to do now is, if you have one, connect Ethernet cable from your device, your laptop, to the actual switch. If you don't have one, I think we have a couple USB NICs if you need one. Let me know if you need one. I can give you a USB NIC. You got this type of USB on there?
Yes.
Any chance we got more USB NICs? Wired NICs? If not, that's fine. Why are laptops moving the way of no USB or no actual NIC, physical NIC? I like laptops with a NIC, like a wired NIC, but why are they moving that way? What's your theory? Like consumer electronics, why, for the most part, do they not have NICs, wired NICs? Slim. Generally, they want them, they're smaller. This requires more space, right? Wireless exists. But I believe for us as IT and cybersecurity professionals to have devices, mobile devices with the capability, whether it's through an adapter or it already has it built in with a NIC, is very helpful. I personally have found it to be very helpful. Cool? Yeah, the speed differences is going to be a stark contrast. So in Packet Tracer, I'm just getting a wired Ethernet cable and plugging it into a switch port. You can watch what I'm doing to see the MAC address. But on the switch, if you have a connection with the switch, go ahead and do show MAC address table. I think that's what it is. I might have missed something there. Sometimes I put a dash when I shouldn't have. Show MAC. Yeah, so it's show MAC address dash table. And my Packet Tracer switch doesn't even have one. Why not? Why hasn't it learned any MAC addresses, even though I've connected this PC? What do you think it needs to start generating traffic? My PC or my laptop here. Yeah, there's one there. There's a connection there. What else do you need other than these physical components that we've built into this network? What else makes up a network that's not just physical? It's logical, often assigned in software. An IP address, right? An IP address is like a phone number for a computer. Every computer that communicates over the internet or over a network has an IP address, including your phone. There's things that have IP addresses that really shouldn't these days. Dog collars and cat collars and teddy bears with microphones built in. Seriously, you got these IoT devices that are like, why does my refrigerator need an IP address? I don't know. I personally don't have one that has one, but I know that they exist. So you can remotely look at what's in the fridge. Like, okay, that's kind of interesting. But yeah, it does make it cool. Okay, IoT is cool. I'm ranting a little bit about it, but it is cool. But it's also opening up a whole world of vulnerabilities, right? Why, from your perspective and your reading and your research, why is IoT creating a security issue? Or why is it in...
to hack into your personal information.
Yeah. More specifically, though, why are people talking about IoT like it's a problem in security? What are...
The devices are made to be highly visible using connection. That's kind of contrary to security. So if you have them on the same network with your stuff that needs to not be accessed by everyone, you have a problem.
Yeah, that's a good point. There's an eternal balance in security, and it's with convenience. You get less security, and less convenient, or more secure, it becomes less convenient. It's really hard to get both. And these IoT devices, if it's a teddy bear toy, there's an app probably, right, that just auto discovers that device and you can play with it, right? And it's not designed to be secure. A lot of IoT devices also, the manufacturers are not regularly doing firmware updates. So it's like you can get this device that was manufactured 5 years ago in some factory somewhere, and it's on that firmware still. And most people aren't going to try to SSH into their teddy bear, download the latest firmware. It's like that's probably not going to happen. So what does that create? Like this teddy bear, let's say it's running Linux, some type of Linux distro, and I connect to it. I got a foothold on the network through the teddy bear. Has that happened? Maybe. I don't know. But it has to have. If it's running an OS with a shell, with like a command line interface, it can be used to pivot. Have y'all ever done any research on the Target breach? They say that it happened through a HVAC system that had a management IP on it that was on the same subnet as the credit card or the point of sale machines that had credit card machines connected to them. And the attackers put memory scraping malware on those point of sale systems, which I think were running some version of Windows 7 embedded or something like that. So every swipe they were scraping that. What was it? Whatever went through memory, it was getting scraped and uploaded to some C2 somewhere, right? So networking matters in that case too, because we want to create these separate segments of a network to keep production systems and more critical systems segmented from guest systems. I'm tired of connecting to some networks, legit organizations. In the guest network, lets me get the IP address of the domain controller. I mean, like, why is the DC on the same network as the guest network? Because they're not logically segmenting them. So when we think about networking, like today, we should think about not just physical components, but it's also very much a logical world of thought. I can't take a magnifying glass over a cable and see everything happening. I have to imagine what it looks like or use Wireshark or something. It's really hard to see it. So that's why I think oftentimes networks just get slapped together instead of built with a secure design, if you will. Does that make sense? Cool. So I need to give this laptop an IP address. So for y'all, if you haven't already, you may want to go into your laptop in Windows. I saw someone was running Linux, a Linux distro in here. There's a place to go where you can just go to your network settings and assign it an IP. In Windows, you can type in search network and sharing or network adapter and pull that up and assign it an IP to it. In Packet Tracer, I'm just going to this generic little area and I'm doing 192. I'm going to do the basic class C, 0, just doing .10. It'll auto-fill. What is a default gateway? Let's get into practical IP addressing. What is a default gateway? When I see that on a computer, what is immediately your thought? The router, right? If you look at the very top device on that stack of equipment, it would be assigned to one of those network interfaces. At home, it's probably virtual because, at home, your device, your router is like what they call an ISR, an integrated services router. It has a bunch of different things it's doing. It's a wireless router. Sometimes it's a file server. It's a bunch of things. But for the most part, it's going to have at least one IP address for your devices on the network to connect to, right? Not just to log into it, but also to route traffic, right? What was it that we said about why, what the difference between a switch and a router is? What is the router doing that a switch generally isn't when you think of a switch?
Switch doesn't give out IPs or DHCP, doesn't do port forwarding, doesn't do any of the things that you need to maintain the network with added usage. Where a switch just delivers what the router does.
It's facilitating connections between devices on a LAN where the main purpose of a router is to route traffic to a different IP subnet. So, for example, I'm opening up Windows now. You can do this with me. Open up command prompt and do IP config. If you're at home, you can do this too. If you're on Windows, it's IP config. Mac, I think it's IF config. And then on Linux, you can generally do IP space add, and it'll give you most of the same information. Well, look at this IP scheme is what is being used on the wireless network here on the Neon Temple. This gateway is .1, right? Does your default gateway always have to be .1? Is that part of the protocol that it's required to give it .1? Why do you often see the default gateway being .1 or .254? Anybody have a guess? But why would that be something the IT admins pick as like, I'm going to make this my gateway, 1 and 254?
Most of them come as default to that either one of those ports.
It does. But if you manually do this, generally that's what do they call it, a de facto standard? It's just something people just got accustomed to doing. Make it the first or the last. Started with somebody and it just became a standard people adopt. Is it required? No. You could have default gateways that are different, and it'll work just the same. But it's just, you'll see .1 or .254 as the primary IP of a default gateway. Cool? If you're at home and you type this in the browser, what happens? I heard somebody say something. Oh. It takes you to a web page, right? Where you can log into your router at home. I want you all to log into your router at home when you go home. If you're at home right now, please try to log into your router. I want you to make sure your router's login interface is not admin or admin password or admin nothing. You can Google I've seen it too much with small and medium-sized businesses. You can go to the gateway and you can type in admin and just enter and I'm in, right? That's an issue. Some people, you know, you can Google the manufacturer of a lot of printers and a lot of routers and they give you the default credentials. That if you can find that, so can the malicious actors or hackers. What could a malicious hacker do with your logged into your router? Realistically, if they were malicious, what can they do?
Yeah, that's poison it. Sniff packers.
They could sniff pack. How about they could enable a VPN? They could have a back door to your network if they want. They basically live at your house with you. You know, you're wondering why the bandwidth is so bad and somebody's in there living in your network, right? So change those, please, for me. Home networking stuff, please change that. Awesome. Does this make sense? Every computer on a network has an IP address. Cool. So I gave this one an IP. I'm going to get another one. What is a tool that I can use to test connectivity on the network? Ping. What is ping? Yeah. Well, ping itself is actually just a program that generates ICMP requests. What is ICMP? I'm so glad you asked. It's a protocol, the Internet Control Message Protocol, and it's designed for testing connectivity. Is ping the only tool that uses ICMP? What's another one that's useful, very useful? Traceroute. What does traceroute do? It does what it says. Every now and then in IT, the names are perfect because they tell you exactly what it does. It traces a route. It traces it where? If you've got a connection right now, try to trace route to Google. So I think it's route in Windows, right? Not trace RT. I'm doing 8.8.8.8. Oh, it's trace RT in Windows. Trace route in Linux. So what is this getting ready to do? What are these numbers and what are they talking about hops? This is not Peter Cottontail. Why is it tracking hops? They're going to be like, look at this man giving away IP addresses and stuff in the network. The thing about networking is you can't hide too much. A lot of it is reliant on being discoverable and being traceable, so it can be hard. It can be really hard to networks are by nature not very secure, just by nature because of discovery in finding devices on the network. So what did this just do? What does this mean? How many hops did it take for my traffic to get to, from here on this network to get to 8.8.8.8? Or was 9 hops? How fast did it get there? Milliseconds, right? What's it say, 11 milliseconds? That's wild. If we did a ping, 8.8.8.8, it sent 4 different ICMP requests. They got there 13 milliseconds, 12 milliseconds, 11 milliseconds, 12 again. That's fast. When I look at networking, I'm dorking out because I'm thinking that this just traveled to Google's data centers in milliseconds, right? And that's one of the things that really got me. It was the click of connecting an Ethernet cable to a switch port. It was like I clicked and it jolted through my body, and I all of a sudden loved networking. And then it was pinging and doing traceroute. Something about seeing it. You can do visual trace route too. You can see maps of where traffic goes in the world. It's really interesting. So ping makes sense. What I would like y'all to do, how many of you are actually connected to one of these switches? At least 2 people? 3? So we have 3 connected. Assign an IP address to your machine and ping one another. Try to ping one another. I'll do it up here. So what I'm doing is, and anyone can do this at home, if you can download Packet Tracer, you will have to create an account with Cisco. It's free though. And you can download Packet Tracer and follow along with what I'm doing. If you're in here in the lab, here at the temple, you can do this on the actual equipment. So you'll go in Packet Tracer, you'll go into the desktop, go to the IP, and then the IP settings, and then assign this IP if you'd like. And then on the other laptop, assign this IP. And I open up command prompt. What operating system is Packet Tracer simulating?
Windows.
Why? How did you know that? Are you a magician? Are you a wizard? How did you know? The C, right? C drive. Windows identifies volumes and drives with a drive letter, right? So that's how we know. And the commands. You know, when you use Packet Tracer, doesn't have all the commands you need, but it has most of them. So what would I ping? How would I test this? Remember the whole purpose of really pinging right here, not just for learning purposes, but also for getting the switch to learn a MAC address. What would I ping? I don't have a gateway on this Packet Tracer environment. I just have another PC. So I'm going to ping this PC's IP address, right? So ping 192.168.0.10. Okay, my network's working, at least the LAN is. I will urge you to use ping and trace route as you build networks. If you get the opportunity to build one in your career, test it as you go. A lot of people try to fly through configurations and then it doesn't work. And you're like, I don't know where to troubleshoot. They start troubleshooting way up here. But if you troubleshoot and you test as you go, you will not have as many problems. I promise, hey, I've made a lot of mistakes in just trying to run through configurations that I know now. Test as you go, especially if you're building complex networks. Cool? What if I'm pinging a Windows machine and I don't get a reply or a successful reply? Because this is a successful reply. What is it? Because I'm terrible at networking and it doesn't work?
Windows just blocks it sometimes by default.
Yeah. By default, what could potentially block an ICMP request? Firewall or Windows Defender firewall. Remember, Windows Defenders is like a security suite now, the Defender firewall, and there's also AV. But yeah, I thought that was interesting. Defender blocks ICMP. Why? Why would they block a perfectly legitimate troubleshooting tool?
I'm just shy.
Shy. They're just shy. That's what someone said. We'll go with that one. No, could be a wide array of things. I don't have the exact answer. I can think of it like, how about just they want you to enable it because they know of attacks like pings of death. Have you ever heard of that? Where it's like, botnets are created that you can ping one device and it's 1,000 or more computers pinging one device and tries to bring it down. This is why generally, on the public facing side, on your public IP address on a router or firewall, you don't generally allow ICMP because they may try to DDoS you with a ping of death. But internally, you probably want to enable it just to have troubleshooting abilities. But on the public-facing side, like your public IP, probably not, because you could have some malicious people or just some kid. Now, quick story on that. The first time I ever did a networking lecture, I was at a library in Statesville, Iredell Statesville Library in North Carolina, and the network admin told me that there was like every day at around 3, their network would come to a crawl. And they eventually installed a Meraki firewall. Have y'all ever heard of Meraki? and they started seeing like where traffic was coming from. They saw ICMP, and what they noticed was this one kid every day would log into, I don't know if you've ever heard of, what is it, low orbit ion cannon? It's like this DDoS tool. He would just every day at like 3, just because he was bored, just DDoS the library network. And it's
on
like
a schedule.
yeah, seriously, they literally saw it. Like the bandwidth was like terrible at that time. So interesting story there. I still remember that. So ping ICMP is generally a good thing, but it can be used for evil, just like most things in IT. Does that make sense? Cool. So we are pinging. We've got IPs. What was our original thing? We wanted to see how switches work, right? So how do I see my MAC address table? Show. Oops. Let me type my password if it's. Yeah. Show MAC address. I think it's dash table. Yep. You see it learned 2 MAC addresses, right? Which MAC addresses did it learn? What are those? Did those just come out of nowhere? Right? The 2 laptops. So if you did that on the switch there, now if you all over there generated traffic, they should be able to also see learned MAC addresses. So when you see, if you plug into a switch for the first time and you see that amber light or orange light, one of the things that switch is doing is learning the MAC address. A couple other things regarding spanning tree happen too. We're not going to get into spanning tree today. It goes beyond the scope of what we're talking about. Cool? Are there any questions so far? I know that we're covering a lot in a short amount of time. But are there any questions about sort of some of these basics, like what are the different devices on a network? What do you need to do to get it working? You feel pretty good about that? You feel good about connecting to a Cisco device? Cool, cool. All right. Now what I want to show you how to do is create a VLAN. Has anybody in here created a VLAN before? We've got a few. What is a VLAN? What's its purpose? Mainly for network segmentation, right? It's a virtual local area network. VLANs are virtualization in networking. So you see VM, virtual machines. Anybody built one or interacted with one? It's like a computer inside a computer. It's the matrix, basically, right? A VLAN is a network inside of another network. When you get into virtualization and networking, that's crazy. Like thinking about how VMware works, and that's amazing to me as well. But why would I create a VLAN? What benefit does it have for me to segment at that level?
Say if you're running a web application and you've got a bunch of different services that have to play nice together, like a Django server, Celery to offload stuff, whatever your database is. You host those in different Docker containers, and you unify them. That way they can all talk to each other cleanly without a huge extra workload and configuration.
Oh, nice. Yeah, so you're thinking about it from a web application perspective. When I think about it like as a network admin managing computers, let's say I have a guest wireless network. Should that go on the same VLAN as my production computers? No. It happens too much though, right? You should have a production network, a production VLAN. You should have management VLANs for like IT to manage, and then you should have guest, right? So let's create 2. Let's create a production VLAN and guest, just as an example. So how do you do it? It's pretty straightforward. One of the easier things to do on a Cisco device. And it's the same. I've been on HP, Juniper device. HP does make network equipment. It was weird. I was like, HP, printers, networking? What? You'd be surprised how many vendors actually make network equipment. So VLAN, I'm going to do VLAN 50 on this one, and I'm going to name it production. Enter, exit, and then I'm going to do VLAN 10. And that'll name that guest. Am I done? I've created VLANs. I'm the best networker ever. We now have VLANs that work for us. What do I need to do next? And this is where, this is a really important distinction in networking. If you take nothing else away from this, I would be okay with you taking away how VLANs work. So a VLAN, what goes in a VLAN on a switch? I'll wait. We need that do 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 do. Devices are going to be in them, but what specifically on the switch will be in a specific VLAN? Switch ports. Yeah. So do this. The reason I'm typing do is when you're in a higher level mode and you're trying to do show commands in Cisco, you type do first. Otherwise, you have to go all the way back down. So do show VLAN. Enter. This is my VLAN table. What do you notice about this VLAN table? Right? We created 10 and 50 with no ports in it. Right? We have to put ports in those VLANs. Which VLAN are all the ports in by default? VLAN 1. Not good form to leave everything in VLAN 1. So let's move those ports into, let's divide them in half, right? Let's just mess with the first 20. So we'll do 10 of the ports will go in VLAN 10 and 10 will go in 50 just to practice with it. So you could do in range F01 through 10, enter. And then do switch port mode access. So access ports go in VLANs. So we do switch port access and then do VLAN. We'll make those in VLAN 10. Enter. And we'll put 11 through 20 and 50. And I'll just go through the process. I'll go int range F011, and this is just the name of those interfaces, through 20. I'm just going to do up because I'm lazy. Up, and then 50. How can I check to see if that worked? What would I type? You remember? Yep. Do show VLAN. And it worked. Did yours? When you typed what? Oh, yours is going to be different. Your switch might have different identifiers. So when you do show VLAN, pay close attention to how your switch identifies its switch ports. Pay close attention to that. It might be like G1/01, but the concept is the same. Cool. How much time we got left? Is 10 minutes?
It kind of depends,
Okay.
If there's going to be a tomorrow, then depends on how far you want to get. Kind of depends on these guys too,
Okay. The next thing I wanted to kind of jump to was the router after VLANs and show NAT, because NAT's really important. So do y'all have time? Can you give me 30 more minutes? I know it said it ends at 9. And I know you're of course free to go whenever. I'm just saying, if you give me 30 more minutes, I'll show you how NAT works. So, cool. What is NAT? What does it do? Yeah, and vice versa, right? So when I communicate over the internet, what does the destination actually see? What IP address? Your public IP, right? Why? Why can't I use private IP addresses directly on the public internet? What's preventing that?
Public IPs are assigned by the ISP, where your local IP or internal IP only comes from the internal network. So there is best not to have them exposed, and that's why the public IPs, even with the DHCP public IPs, it's not allowed.
Yeah.
It's kind of an inside rule that you don't do it.
Right, right.
You want to stay alive.
A lot of ISPs will actually put in ACLs or firewall rules that block private IP addresses incoming. So it will not allow the source to get through unless it's a public IP address or within that range, which I showed in a slide earlier. And you don't have to know them all off the top of your head. Just know for now, NAT translates private IP addresses to one public IP generally. What else does it use other than public IPs? Ports, logical ports, or PAT. Have you heard of that term? Port address translation. So you translate private IPs and the connections when they go through the router, they get translated to a public IP address, and there's also a port, or they call that a socket. The combination of an IP address and a port is a socket. Cool? Does that make sense? Generally, the concept of NAT. Does it make sense why NAT has slowed IPv6 adoption down? Because IPv4 addresses are exhausted, right? Like there's no more created, no new addresses created, they're all gone. But the fact that you have NAT and still public IPv4 addresses out there, NAT makes it so that your internal IP scheme really doesn't matter because it's just translating to a public IP address anyways. Does that make sense? What can you use NAT for? And how would I use NAT to allow traffic to come from outside of my network or outside on the internet into my network? What would I have to do? Some people do this with Minecraft servers. You got a port forward, right? What is that doing? Technically, it's creating an entry in the NAT table, the translation table, that says anything going to this public IP and port, redirect it to this private IP address on the internal network. So you're basically telling your router, if it connects on this IP and this port, redirect it, reroute it to this IP address on my internal network. Does that make sense? Port forwarding is a tricky thing because you're opening up your internal network to outside connections without you initiating it, right? Because generally, if you think about how home networking works, it's mostly requests are generated internally first, right? Like from Windows out to the internet. It's not internet coming in, right? Or devices coming from outside. Like if I'm doing Windows Update, my computer is generating the request first. And that's usually what you want it to be. You don't want it to be able to come in by itself without you initiating that request. Cool? So how do you do it is the next question. It already works on a home router, right? But when you get into a business environment, if you're helping a business out, maybe a small one, and you're bringing in a new router for them or something, and you want to use that router or firewall, you're going to have to interact with NAT most of the time. Whether you're bridging the modem, anybody ever done this? Like you bridge a modem that an ISP gives you, or router, modem, combo, whatever, bridge it to the actual appliance you bring in. That's generally how it's done, and it goes right to the firewall. Which, how many of you have done any firewalling? We're not doing that today, but firewalls, that Gucci Home Lab setup over there, there's a firewall over there. You say pfSense is what it's running? If y'all ever get a chance to get experience doing that, that's a valuable skill set. Network security stuff, these companies are looking for people. Good. That's awesome. So firewall stuff is another big thing. And I'm talking network firewall, not just host firewall. Cool? So NAT, there's a router. And this is the challenge of the day. That router has a connection. You see the black cable running off that router? That's like the second one from the top. That's running back into the telecommunications closet or data center here at the temple, and it has an internet connection. The goal that I want y'all to accomplish, you can work together to do this, and I will show how to do NAT, but you got to put it together. The goal before the end of tonight, I would like to see y'all have an internet connection through your network topology there. Meaning someone can physically connect a switch and get an internet connection through that router. So what you'll have to do, I'm going to give you the steps. You just have to translate it into that topology over there. You're going to need to make a connection from your switch, at least one, to the router. This router already has a connection somewhere else. It's going to, think of the Neon Temple as the ISP. And the Neon Temple ISP network is 192.168.70. The default gateway on that network is .1. So what you're going to need to do on this router, and I'll show you how to do all this, is you're going to, one, need to assign an IP address, at least one, that's going to be the default gateway for your laptops, right? Because your laptops need to get out to the internet. They need to know what device they need to send traffic to if it's not on the LAN, right? And that's what a default gateway is. So to do that, you actually have to give the router an IP. So you're going to need to find out how this router identifies its interfaces, and I'll show you how to do that. You can do show IP int brief, and it'll give you the interface numbers. So will the front. If you look at the label on the front of the router, it's like a yellow tape. It'll tell you the interface, and you'll want to do int, go into global config mode, do int G00, or whatever your interface is. Give that a default gateway. So you can do IP add type. I'm going to use 192.168.0.1 255.255.255.0. Enter. And Cisco's got weird terminology. To turn on an interface, you're going to tell it to no shut. Why didn't they say on? I have no clue. Like just no shut, okay? Because to shut it down, you type shut or shut down. But when you no shut, you're removing shutdown. It's really weird.
Be careful with shut. If you're over SSH or Telnet and you shut the computer on, guess what happens?
I've done that.
No more access.
I've done that.
That's a pain when the switch is a quarter mile away in a different building.
Yep, because guess what you're doing? Road trip, right? Yeah. So no shut. I've given it an IP. This is where NAT can get tricky for people because it combines a bunch of different concepts, right? I'm going to give another interface an IP, right? So this interface here that's going in that scenario, that interface is going to a switch port that has an internet connection. So you're going to go into that interface. Make sure you look at the one with the black cable connected to it. So I'm doing int G01 just as an example. And you're going to want to give that interface an IP address on the 70 network. You don't have to give it, you shouldn't give it 70.1 because 70.1 is already assigned at the telecommunications closet. You could do like 70.100. You could do like IP add 192.168.70.100. And then the subnet mask, enter. And you're going to want to do, it might have already been done, the no shut on that one as well. And now you've just assigned IPs, right? How many IPs did we assign to the router? 2. One for your LAN, so your table that you've set up, and one for your WAN, which is your ISP, right? The Temple ISP. You're connecting to that. So you have that IP for your LAN and the IP for the Temple, right? This is where there's some concepts I'll have to explain. This is where we configure NAT. Has anybody done this on a Cisco device? Because there's a few different topics that come into play. Anybody online? I don't see the chat, so I can't tell. But if you have, great, let's do it again. So the first thing you want to do when you configure NAT on a Cisco device is you want to define which interface is going to be your inside interface and which interface will be your outside. So you're going to do int G00, which in my case is inside. For you, you want to pay close attention to what's going to your LAN. The interface that goes to your LAN is your inside interface. So this is my inside interface in my packet tracer topology. Be cognizant of that because this is all in packet tracer. Do IP NAT inside. That's all you do in that interface. We just defined it. It's the inside interface. Then we go to the outside. This is what's going to the Temple ISP. Do IP NAT outside. Enter. So we've defined our inside interface and our outside. Now we need to create what's called a network-based access control list. You know what an access control list is? It's like when I think of an ACL, if I personify it, I'm thinking about like a bouncer at a club. He's like, "You're on the list? Yep, go ahead. Yep, no, you know." What's in every ACL? It's at the bottom of every ACL, even in Windows file sharing permissions. Implicit deny, exactly. So if it's not allowed, it's denied, right? So if you put, you have to be careful in configuring ACLs manually like this, because in this case it doesn't matter, but in a production environment, if you create an ACL or you edit an ACL, you don't want to wipe the whole ACL. You want to save the configs, make sure your configurations are added, not overwriting, because you might blow away firewall rules. So in this case, this is how we create an access control list in Cisco. You do IP access control. Is it access list? Let me see. Yep, IP access list. We're doing standard. Standard just blocks based on it permits or denies based on source IP address. Extended does a lot more. Source, destination, IP, port, it does a lot more. We're going to name it NAT overload, and then we're ready to configure it. So I hit enter. All I've done is basically create like a text file named NAT overload. I'm going to now configure it. Do you know what I'm going to put in this ACL? What would I put in here? Yeah, they said they'll stay a little bit. You know what I would put? What would I permit?
The two IPs that we just assigned?
You want to permit that whole network. But you're right. You're thinking the right way. Do permit, right? So I'm doing 192.168.0.0 because that's what I did in Packet Tracer. But for y'all, you're going to put whatever network you picked. Then I'll do a wildcard mask. Y'all know what that is? It's the reverse of a subnet mask. So enter. And then we're done with the ACL configuration. Now we got to just tell that ACL how we're going to use it. We do IP NAT inside source. I know it's a lot. List, the name of the list, and then we say which interface we want it to translate to, which would be the outside. So whatever's going to the ISP. So you do int G0 or whatever yours is going outside. Enter. What's the last thing I need to do? How will this device know where to route? What should we route to? You want to route to your gateway. So we're going to create a static route, and that'll be the last thing we do. I know we did a lot today. IP, so the way you create a static route, IP route, and we're doing a gateway of last resort. This means to anywhere. Then I'm going to do, in this case, I would do 192.168.70.1. It's where my IP route, where am I going, and how am I going to get there. And now you should be able to route out, assuming they didn't disconnect it. But that's pretty much what I had for today. I'm curious to see if y'all in here can get that working. We probably don't have much more time, but if you're willing to give up a little bit, I know we'll stay a little bit extra to see if you can get it. I'll hang around to help. If you're doing this online, I recommend do it in Packet Tracer. If you have a network stack at home, try that on that stack. You could do this at home too. Cool. Y'all got questions?
Sure, there's some online.
Let me check here.
You have a good point, Bob?
Yeah.
Any immediate questions in the room? There was none on YouTube at the moment about it.
Yeah, I didn't see it either.
So, okay, I know we got a few people here that are actually still actively working and doing stuff. What we're gonna do, for those of you on the stream, sorry for your luck, should have been here. I know the wife's watching, she's gonna be mad I'm cutting you off, but she sees you every day, so she can deal with that for a bit. He's mine this weekend, deal with it. We're gonna cut out, we're gonna let the stream go. For those of you that are here, feel free to stay here, get hands-on as long as you want. The door's open, if I'm here, you can be here. So, until next time, guys. Thanks for showing up again, Bob, and doing the
no
workshop.
problem.
For those of you that are here, feel free to keep working. Take us out, Chris.